Hello students, welcome into the another session of CS02 Programming in C. We are discussing about unit number 3 and the topic called memory allocation function. In memory allocation function, as per the syllabus, we have to discuss about the three different types of functions, that is melloc, realloc and calloc, which is selected onto the screen. So let's start with the same. First, we'll discuss about melloc function. Now as you can see onto the screen, this name called melloc stands for memory allocation. Generally, these three functions are used with the concept of pointer available in C. So we'll practically demonstrate all these three functions when we are starting with the last unit of our entire subject, that is called as pointer. Right now we'll see the theoretical session as well as the syntactical part of this three function. So again I'm repeating my words. Melloc is a standard memory allocation function which is used to reverse a block of memory of the specific number of bytes, and it returns a pointer of void which can be casted into the pointer of any form. Again I am repeating my word. Melloc is a standard memory allocation function which is used to reserve the block of memory in a specific bytes, and it returns a pointer of void in which pointer points into the form. The syntax of malloc is given on a very next line of code, where you can see that there is a one variable called ptr, then into the bracket I have passed the data type, and then I have written the malloc function with the parametric value which indicates the size of the byte which is occupied by this particular function. Now whenever we write the statement like ptr into the bracket float pointer malloc 100 multiply by the size of float, then by default it will occupy 400 bytes into the system for storing the value inside the system which is entered by the user. Now similar like a function is calloc, which is given over here. This calloc function have the functionality like this one. The calloc stands for continuous allocation, that means continuous memory allocation. The malloc function allocates the memory and leave the memory unutilized, while the calloc function allocates the memory and initialize all bytes to 0. So we can say that calloc function is more reusable than the malloc function. Now the syntax of using calloc function is given on a very next line of code, where you can see that there is a ptr is equals to type, that is data type, calloc into the bracket n comma size. So the pointer variable is equals to float pointer calloc comma into the bracket 25 comma the size of float. The above statement continuously allocates the memory space of the type called floating for the 25 elements. So this is the functionality of calloc. Now the third one is reallocate. All the theoretical part is same into the reallocate, but as the name is suggested, reallocates the new size of a variable into the memory allocation by just writing a name called ptr is equal to reallocate into the bracket ptr comma x, where it reallocates the memory inside the system. So this is a small theoretical session related to the three dynamic memory allocation function, that is malloc, realloc and calloc. Now the next topic is type of user defined function. If you remember, then we have taken lots many session for this particular option which is given into the single statement in our syllabus, that is types of function. We have discussed four different types of function, that is function with argument with return value, with practical, function with argument without return value, with practical, function without argument with return value with practical, and function without argument without return value with practical session. So this is already done in our unit number 4 while we have discussed about array and structure. After that there is a pointer. So already we have a unit number 5 in which we have to discuss in detail about the pointer. So this topic will discuss into the unit number 5, that is called as pointer. Now after that there are two option, function called by value and function called by reference. This is very important for university examination point of view. We'll discuss it right now. The question may be asked like this: give the difference between function called by value and function called by reference, or individually the question may be asked like that: write a short note on call by value, or you can say the write a short note on function called by value. But as per my point of view, the difference is more important than describing each separately. That is, the question is very important: give the difference between function called by value and function called by reference. So the difference is given onto the screen, where you can see that first of all, always the difference is described into the table format. So on one side I have written call by value and its topic, and on another side I have written call by reference and the difference topic, then call by value. Now I have bifurcated call by value and call by reference based on some topics, that is the definition difference between these two, then arguments difference, effect difference, alteration of value, passing of value, value modification, memory allocation difference, safety difference, and the default difference between these two. So first difference between call by value and call by reference, as far as the definition is concerned, given onto the screen. In call by value, while calling the function, when you pass a value by copying variable, it is known as call by value. Again I am repeating my words. While calling the function, when you pass a value by copying the variable, it is called as call by value. And on another side, call by reference means, in short, whenever you are calling the function by its address, that is called call by reference. The detail is given like this: while calling a function in programming language, instead of copying the value of variable, the address of variable is used. It is known as call by reference. So the difference is, call by value is used where used value to call the function, while call by reference use the address to call the reference. Now the next difference is argument. In this method, copy of variable is passed, while in call by reference, variable itself is passed. That means whenever we use call by value, entire variable is passed into the call by value, while in call by reference, variable itself is passed for calling the values. Next is effect. Change meant in copy of variable never modify the value of variable outside the function, while in call by reference, the change of variable also affects the value of variable which is outside the function. Means if we are using call by value, then copy of variable cannot be modified outside the function called, while in call by reference, whatever the changes that we have done reflects even though outside the function. Next is alteration of value. Call by value does not allow to make any change into the actual variable, while call by reference, as it passes the address of variable, then it allows to change, to alter anything during function call. Next is passing of variable. value of variable are passed using straightforward method, while pointer variable are required to store the address of variable. That means in general, without using pointer, suppose you want to call the function, then we need to go for the UDF type, that is called as call by call by value. And suppose we want to go for the specialized technique using the pointer, then we have to use call by reference. So using pointer, call by reference can be used, and with normal, call by value is used into the C. Next is value modification. In call by value, original value cannot be modified, which is passed into the function, while in call by reference, original value can also be modified. This is the value based difference between call by value and call by reference. Next is memory allocation, or you can say memory location. Actual and formal argument will be created in different memory allocation. That means call by value use different memory allocation for storing the different value, while in call by reference, actual and formal argument will be created into the same memory allocation. That means the better performance we will get using call by reference. Next is safety. Actual argument remains safe as they cannot be modified accidentally. While actual arguments are not safe, they can be accidentally modified. You need to handle arguments operational very carefully while you are using call by reference. So even there is a pros and cons about using the call by value as well as call by reference. And the last difference between these two topics is the default difference. In default in many programming languages like C, PHP, Visual Basic, .NET and C Sharp, they used call by value only, while in Java object-oriented programming and the higher language, call by reference is used for calling the function which has been declared into the program. So these are the differences between function call by value and call by reference. Next topic is recursion. We'll keep this topic into the pointer itself. So whenever we'll go for unit number 5 called pointer, we'll discuss about the recursion. Next topic is storage classes, which is very important for university exam theory. Maybe ask like this: write a short note on different storage classes, or we can say that describe storage classes in detail. So first we need to clear that what is storage class. Storage class means it is actually a one type of various way to declare variable. Now it looks strange. Up to this we are only aware with declaring the variable like this. That means just write down the library statements like hash include stdio.h, hash include console input output.h, then write down void main and into the bracket integer a. This is the way up till now we are declaring the variables. Now this strategy can be changed by discussing various types of storage classes. So storage classes will teach us various ways to declare a variable. So let's see how many other types of variable declaration, or what are the different types of way for declaring the variables are there in C. So that list is given onto the screen. The list is auto, register, static and extern. Let me take this to the notepad. These are the four different types: auto, register, static and extern. So apart from these four, what we have used up till the last program. So we have used this selected statement up to the last program that we have done, that is called as static. Now this static can be used in two different ways, that is static local and static global. Even extern can be used in two different ways, extern local, extern global. We'll discuss each and every storage classes in detail. So that detail is given over here. Say for example, what is auto? Auto is actually a one type of keyword which is put before the variable declaration with its data type. Say for example, here I have declared an variable called a with integer. Before that, suppose I write auto, then this variable a is declared with auto storage class. Now what is the functionality of auto storage class? The auto storage class is the default storage class for all local variables. The example is given like this, where we have declared a one variable called a with integer data type and the auto storage class. That means automatically it will store the value inside the variable called a, which is declared as a integer data type. Next is register. Now to use register, simply just replace this auto with register. This is the way of using register storage class in C. Even you can see even you can see over here too. The theory says that the register storage class is used to define local variables that should be stored in a register instead of RAM. This means that variable has maximum size equals to the register size and cannot have the unary AND operator applied to all. So we can say that if we are writing the register, by default, suppose we are not writing anything, then this variable and its value is stored inside random access memory location by writing the keyword called register. The memory allocation scenario gets changed, and instead of RAM, it stores your variable's value into the register of a computer system. So this is the functionality of register. Next is static. Simply by changing this keyword called static, simply by changing the keyword called register with static, in this way we can declare a static variable in which the static storage class instructs the compiler to keep local variable in existence during the lifetime of the period instead of creating and deploying each time it comes into the go out the scope, therefore making the local variable static allow them to maintain their value between the function call. Now for checking this particular scenario, what we are doing is we are just simply writing a one basic program in which what I am doing is first a simple variable declaration that I am doing, that is CLRSCR, that means integer a, next line CLRSCR printf, enter your value, then scanf %d and %a, and then simply I am printing printf %d comma a. Let me run this code. Suppose I enter 2, then this program will display 2 onto the screen. It's a very simple and the general program in which static variable declaration I have done by writing the keyword called static. Say for example I execute this code, it returns 7 onto the screen as I have entered inputted the value called 7. This is static local. Now I am changing one thing in this program. I am writing static integer a, but before that let me demonstrate one more thing for all of you. Here I am declaring one function called test with function without argument, without return value, and I am calling that particular function from void main statement, and then I am initializing this particular function after the closing bracket of void main statement by writing the line void test brackets and into the brackets of test. Here I am writing printf %d comma a, and the same line I am commenting into the void main statement. Now what will be the output of this particular program? It returns one message that is undefined symbol a. Why it returns this message? Because a is declared inside the void main statement and it cannot be accessible outside the closing bracket of void main statement, and I am trying to access that variable into the test function which is outside the bounding of a. That's why it returns this particular message. Now what I am doing is I am just taking the copy of this variable declaration statement and I am putting that statement outside the void main statement, and then I am running the program. The error automatically gets removed. There is no syntactical error. Let me execute the code and let me enter the value. It returns the same value onto the screen, and the strategy that I have developed is called as global variable declaration. So if you write this type of variable declaration outside the void main statement, that is called as static global declaration. And if you write anyone you can use, and if you write inside this statement, inside the void main statement, then that is called as local variable declaration. So this is the difference between global variable declaration and static variable declaration. If we use global variable declaration, then it can be globally used in any of the statement in a same program. That means I am using a into the void main statement, even the function which I have created. This program is not that much important for university point of view. I am just clearing the doubt between the static and global variable declaration through this simple code. Without wasting more time, let's go ahead. Next one is extern. By simply just changing the keyword called static to extern, we can have a use of extern storage class. The extern storage class is used to give a reference to a global variable that is visible to all the program files. When we use extern, the variable cannot be initialized to the storage location that has been previously defined. Again, I am repeating my words. The extern storage class is used to give a reference of global variable that is visible to all the program files. When we use the extern variable, it cannot be initialized into the storage location which is previously declared or defined. Now, this is the way of using extern variable. Simple program here I am given. Let me take into the notepad. This is the code. It looks similar like the global variable declaration. In this program, you can see that after the necessary library function, a one variable that I have declared is a count variable with integer data type, and into the void main statement, I am initializing the value of that variable with 5, and then with the help of printf statement, I am printing the value of initialized variable onto the screen by just writing printf %d comma count. So this is the way of using the storage class that is called as register. The next topic is again we are going to cover into the unit number 5, that is passing and returning the value into the pointer. So the bunch of pointer we'll shortly discuss in unit number 5. So this was all about the topic which is given into the unit number 3. In next lecture, we'll start with the unit called pointer and all the remaining left topic of chapter number 3, unit number 3. Thank you very much students for listening me, and have a nice day.